You know, for pretty much our whole lives, most of us have been taught to add numbers in a way that just feels completely backwards. Today, we're going to talk about why that is, and more importantly, how to fix it.
I mean, seriously, think about it for a second. We read words, sentences, even big numbers, starting from the left and moving to the right. But the second we need to add them up, we're told to jump all the way to the end and work backwards. It makes mental math a total pain, it feels completely unnatural, and it turns out it's not the only way to do it.
So, what if I told you there's another method, one that's rooted in these ancient principles from Vedic mathematics, a system that's famous for being incredibly efficient and perfect for mental math? Just like this quote says, there's a much more direct path to the answer, one that actually flows in the same direction you already think. And that brings us to the left-to-right method. This is an elegant, really powerful technique that just aligns with our natural instincts. It makes doing math in your head so much faster and way more intuitive than that old way of carrying ones all over the page.
So, what is it exactly? Well, it's actually beautifully simple. You add column by column, from left to right, building your answer as you go. No more jumping to the end and working your way back. You start right at the beginning, just like you're reading a book.
Okay, so to get this down, there's really just one new rule you need to wrap your head around. When you add a column and get a two-digit number, let's say 14, you don't carry that 1 times forward. Instead, you add it back to the total you've already started building. So if your answer started with a 7, it now becomes an 8. You're just constantly updating your running total from the front.
Look, the best way to really get this is to just do it. So for the next couple of minutes, let's solve some problems together. I promise you, you're going to get the hang of this incredibly fast.
All right, let's get into it. Here's our first problem, 478 plus 345. I want you to forget everything you learned in school. We are starting from the left.
First column, 4 plus 3, that's 7. Simple enough, right? This is the first digit of our final answer. We're on our way.
Okay, now let's move to the middle column. 7 plus 4 equals 11. And here's where the magic happens. Because 11 is a two-digit number, we take that first digit, the 1, and we add it back to our previous total of 7. So that 7 becomes an 8. Then we just keep the second digit, which is also a 1. Our running answer is now 81. You see that? We're literally building the number from the front.
And now for the final column. 8 plus 5 is 13. We apply that rule one last time. The sum is 13, so we take that 1 and add it to our running total of 81. So 81 becomes 82. We keep the 3, and that's it. The final answer is 823. No messy carrying, just a simple, clean, flowing calculation.
See how that flows? It's amazing, right? Once you really grasp that one rule, the whole process just clicks into place. Let's run through a few more examples to really lock it in.
Okay, take a look at these examples. For 58 plus 34, see how the carry from the second column turns our initial 8 into a 9? That gives us 92. It's the same exact pattern every single time. Now check out that last problem. Our first sum is 12. The next column's sum is 7, so there's no carry. Our running total is 127. Then the final column has a carry, which updates that to 128, giving us 1285. Feel free to pause here and just trace that logic for yourself.
Now, the real beauty of this whole thing is how consistent it is. The method doesn't get any harder with bigger numbers. The process stays exactly the same no matter how many digits you're dealing with.
Let's watch this first one build together. We start with 2 plus 3, that's 5. Easy. Next, 6 plus 7 is 13. So that carry updates the 5 to a 6, and we keep the 3. Our answer is now 63. See how with each step we're just tacking on another digit, and sometimes updating the number right before it. The logic is perfect, no matter how big the numbers get.
So, at this point, you're probably asking a really practical question. What about decimals? Does sticking that little dot in the middle of the number completely break the system?
And the answer is a big, resounding no. It works absolutely perfectly. The decimal point is just a marker, right? It doesn't change the underlying logic of adding left to right 1 bit.
Let's prove it with 54.21 plus 38.92. You follow the exact same steps we've been doing this whole time. 5 plus 3 is 8, but the next column has a carry, so that 8 gets updated to a 9, and you just keep going. You simply place the decimal point where it belongs, and the process continues. The final answer, as you can see, is 93.13. It's that consistent.
Okay, so you've seen the method, you've walked through the examples, now let's talk about how to make this feel as natural and easy as reading a sentence.
The reason this feels so good for mental math is because you're building the answer from the most important digit first. You're saying the 800 part of the answer before you even figure out the 23. This is actually how our brains naturally try to estimate and calculate anyway. You know, the trickiest part of learning this is just getting the rhythm down. It can feel a little weird at first to go back and update a number you thought you already had. So practice this little flow. Calculate the sum, check for a carry, update the total, and then keep the last digit. With just a little bit of practice, that sequence becomes completely automatic. You'll be doing it without even thinking.
So there you have it, a faster, more intuitive way to add. It really makes you wonder, doesn't it? If we've been doing something as basic as addition backwards for so long, what other established rules out there are just waiting for a better, more logical approach? Definitely something to think about.